to my webinar. My name is Glen Chang. I'm a lead technical artist at Blizzard for the incubation projects. I've worked at Blizzard for 10 years and I've helped ship games like World of Warcraft, Diablo, Overwatch, and now I'm on an exciting new incubation project. My talk today is about a tools approach for rapid iteration in Maya. This talk is for game teams that have chosen to start a new project in Maya, and it can also help game teams that are trying to move or migrate into using Maya as a primary source of content creation. So why this topic? Blizzard usually takes a long time to release a game, and a project can go anywhere from 3 to 5 years, depending on the effort and size. However, that's the production phase. That's where we polish an experience to the best that it could ever be. This talk is not about that. This talk is really about how to go about incubation and how to use Maya as a tool for that development. In this talk, I will focus on the iteration tools for the incubation and the pre-production phase. You can really have a good idea when you start a project, but if you can't execute it to find the fun or the gameplay, then you really won't make it into production. This is why it's very important to iterate fast and to develop tools that can let you iterate fast and try out new ideas, and then allow you a better chance at success. So in the beginning, you'll first start off in the incubation phase. This is the most important step, where the designers and art leads need to iterate fast and develop the vision for the idea. The team itself is a tool, and if you think of it like that, then a slow tool is not a good tool at all. So the best thing you can do is to make sure that the team is operating as fast as it can be for being able to execute those ideas. The ignorant approach is to think that you should start writing tools immediately, and that's not the right answer, because you'll be wasting a lot of time that way. If you invest your time into writing tools, then you're not getting the time to put things into the content of the game, and you're not really executing your ideas. You're just writing more and more tools that you have to support and maintain. So there's just so many ways that a project can fail, and that's not where you want to spend your time. The team needs to iterate a lot of content really fast. So the best thing you can do at that point is to use what already exists out there. It doesn't mean that you shouldn't write tools at all, but it means that you should leverage what exists already, so that you don't have to rewrite anything that already exists. So at first, we'll breeze through some of the startup solutions, things that you'll use for modeling, rigging, animation retargeting, and exporting. Then we'll go through some of the native tools that Maya already has to help you out for this. And then we'll explore some external tools that even Blizzard uses to speed up that process. And then hopefully, if you're lucky enough, you get into the pre-production phase and you get your project greenlit for that. And now this is where I call the need or greed stage. It's where you need to really think about what you need. These are the tools that are blocking your way to ship, and those are the tools that you should really spend your time on. The tools that you define as greed are the tools that are nice to haves. You don't really need them to ship, but if you spend time on them, they are actually blocking your time to go to ship. So you really have to really spend time to define those two. Once you define what you need, then we'll go through some examples of how you can customize Maya, and some examples that some Blizzard examples that are used for incubation projects. Finally, when you're close to getting to production, you'll maybe consider doing some outsourcing, and here's where we can explore how you can create really how you can set up packages really fast using some really simple steps in Maya. And finally, if you can get through all of that, you might survive the journey to get into production. So when you start up, now you're in the incubation phase. We'll dive a little bit deeper into that. don't start thinking that you need to write a tool for this and for that. Start thinking, what's the least amount of work you can do to get a pipeline up and running? You need to iterate fast and you need to fail fast. So, because you don't know if your project will make it, right? You don't want to spend too much time on something when you don't know if you're even going to make it past a certain stage. So, let's focus on modeling. Most studios will have a pipeline that will use tools like ZBrush, Mudbox, Roto, and then they'll retopologize it. They'll use tools like Xnormal and Toolbag. You can even use the modeling tools in Maya to retopologize, like the quad draw. There's quite an extensive amount of tools that exist for modeling that make it really, really fast. So there's not really much tweaking or customization you need to do there to get a pipeline up and running. And the same for texturing. For texturing, you will end up using ZBrush, 3D Code, Substance, really whatever your team would like to use. Most teams also then touch up with Photoshop. Again, this is not really a place where you need much customization. It's already a very well-defined pipeline, and you don't really have to use anything to design or solve any problems. There is one tool I would like to mention though. This is an external tool. There's a tool called PSD to 3D by ED Films. This is a tool that we use in incubation for one of our projects, and it's been really, really good for solving a problem that Maya doesn't do very well, which is it allows you to split up PSD layers from Photoshop and project them out into 3D space so that you can make cutouts. And so this is an example of how it works. You can see here that in this example of their demo, they had created a PSD layer of a character and a setup environment, and they're able to completely turn that into a 3D environment. Next up is rigging. And so in rigging, you don't really want to spend time customizing a rigging solution. That process alone can consume a lot of time. So if you're not a big studio, if you don't already have tools that exist, we don't tend to use these tools because we already do have tools that exist, but I would recommend using tools like M-Gear or Advanced Skeleton because they're already well defined and they're very popular rigging solutions out there. You'll likely find a lot of support just on the web and with users that are already using the tools. For animation, Maya is like one of the best animation packages out there. So already by starting with Maya, you don't have to really customize or create tools for because Maya already does a lot. There is a suite called Animbot by Alan Camilo. That's a very popular choice between all animators. They swear by it, and most studios would actually buy this tool because animators really love using it. I would definitely recommend looking into that one. And then for animation retargeting, Maya already does this very well. It has the Kadara human IK already built into it. And with that solution, you can see that in World of Warcraft, we were able to retarget any one of our animations to multiple characters of multiple dimensions and proportions. And it really works really well. So there's not much customization you need to do there too. So just starting with that already allows you to have a full animation pipeline. Then finally, you need a way to export all of your stuff into game. And the Maya Game Exporter is already a very good tool for that. It's actually very robust in that it can already create tracks for every single animation. It allows you to preview everything. It allows you to specify the start and end frames for all of the tracks. It allows you to also export all of the tracks as a single FBX file or a multiple file export where every track is separated. So if you start off with just all of these, you already have a full pipeline. So hopefully with all of this, you eventually get to pre-production. And you didn't even have to touch customizing any tool. You're just using everything that already exists. Sure, you might have some problems that you might have to write a custom solution for, but at least it's minimal. And then it can buy you all that time to focus more on iterating your ideas, right? And if you get to pre-production, you'll have to really think about this need or greed stage. This is where you have to think about things like, do you really need to reproduce your game shaders in Maya? Do you really need to create a custom exporter? Do you really need those fancy rigs? And do you really need to automate batching? So once you can figure out if your game is blocked by some of these questions, then you actually know what are the tools that you should be spending your time on. So let's visit a common case problem and a Blizzard approach to it. So the idea of your game maybe has a lot of characters, and you need to make a lot of them. And characters can be anything: biped, quadrupeds, flying creatures, crawling creatures, etc. And you want to iterate fast and fail fast so that the designers and the art leads can have as much iteration as possible. So here's an example where we want to iterate characters for deformation. So this is a problem that we wanted to solve during the pre-production phase where, for example, you want to build the characters faster, you want to modularize the limbs for reuse, and you want to iterate with modelers. So basically, you want to have a conversation between the rigger and the modeler so that they can make sure that they are designing a character that can move properly for the animator and can have all the parts and all the limbs and the secondary motion that can convey the gameplay that's needed for the user feedback during gameplay. And you also need a way to save and load the process. So this is a tool that I've written for the incubation project called the skeleton tool. All it is it's a tool that allows you to export something that's in the blockout phase, get it into a rigger's hands, allow him to populate a skeleton for it. In this example, you would normally get a full character, but I'm using just hands just to show a simpler example. The tool allows you to name joints really quickly. It iterates like the numerical order of the joints really fast. It auto-colorizes the left side, the middle side, or the right side, and it allows you to have like some pretty handful tools like making the model X-ray so you can see the joints, or showing the local rotation axes. And in this example, you can see that I'm placing the joints into a hand, and this allows me to start a conversation with the modeler and say, like, oh, the hands are placed right. I can see that I can close a fist this way. And if not, then you catch it early in the blockout phase before the modeler gets too deep within the polishing of that character. And in this example here, you can see that I'm also now I'm orientating the joints, and I can set and define which ways are the up vectors and really define if all these joints will be able to move properly with the way the model is created. And then finally, no skeleton tool is quite complete without the ability to mirror. And hopefully you have all of that in that tool. So designing a tool like this can help you catch errors quickly and focus on the iteration of the model so that you can have less rework. And it also allows you to start a conversation between the rigging team and the modeling team. The next is the iteration between the rigging team and the animation team. So to develop characters really quickly, you also need to focus on that, right? So you want to be able to get the characters into the game immediately. So this means that while still in the blockout phase, when you haven't really started painting the character yet, you're just working with a silhouette, you're getting the character rigged with a blockout rig really quickly, you are able to give it to an animator at a certain point to try to animate some blocky steps to it, and then he can get it into the game right away with some exporter that you've chosen or that you've rewritten, and then it allows you to automate all of that, and then hopefully you can save and load that process. So this is an example of our solution for it. We use a Cinemax tool that Cinemax has already well-defined a modularized tool that can handle many characters. It was written by a TD or two TDs, Chris Luce and Vinod Malabudu, and with this tool, many of the incubation projects can pretty much build any character and automate the building of them pretty quickly. So this is an example of it. Here you can see that the left side, the tool is composed of many nodes in a hierarchy, and each one of these nodes has different attributes, and each one of these nodes also allow the addition of more scripts, and all of these scripts allow the taking in of fields and inputs so that you can build a full rig and repeat that process. At the same time, you can also move the nodes back and forth. You can copy and paste them to other rigs, so you can reproduce a limb like a left arm and reproduce it again to another rig. Here you can see that I'm also doing some special work that's needed for a rig. So even after you've built a rig, maybe your game cannot use, if you need to scale a rig like this one, and it's a squash and stretch rig, you might need to be able to, your game might not be able to have non-uniform scale, especially on the non-leaf joints, basically branch joints. So in this example, I was able to take all the joints that were squashing and stretching and make sure that they are exported as leaf joints. And then the next is the iteration of game assets. And the only way to really get this to be quicker is to create your own exporter, right? So you want to be able to export your objects really quickly. You want to allow artists to be a little bit messy. That's because it takes a lot of time for an artist to clean up a scene. Sometimes they need a reference, or they need like a character in the scene. Even though if they're exporting a weapon, just having a character in the scene will allow to give them a sense of scale. They also need a way to validate their data, right? And they also need a way to set up in-game data before it's exported. So hopefully the exporter that you design will be able to do all of that. So this is an example of a model exporter that we use for incubation. It is a set exporter, very much like the game exporter for Maya, but except this one allows you to specify multiple sets, right? And it allows you to rename them, add, remove nodes, and what its strengths are is that it can detect if you have a skinned model or not, or a non-deformed model. And if it's a deformed model, it will find the influences that are deforming that skin, and it'll export the joints as well. If it's a non-deformed skin, or if it's a non-deformed model, then it'll just export it as is. The one additional feature it can do, as you can see in this layout of weapons, is it allows artists to lay out their kits or their models in a way that they understand. They don't have to keep everything laid out at the origin. And what the tool will do is it will zero out all of these tools back to the origin, export them, and then place them back. And this is really helpful for model kits, right? Where the environment team is trying to create a kit that looks right for an environment, but they have all these pieces that need to be placed in the world space for some point. But in the game, they need to be zeroed out. So the exporter should be doing that. And let's see here. It also allows artists to be messy, which is great because like as I said before, with all these weapons, there's no reference for scale. So it's nice to be able to import a character into the scene, leave him there for the scale reference, but because he's not on an export set, he'll never be exported. So it allows the artist to be comfortable with their own environment, with how they set it up, and they can work basically the way they want. Here's another example of a tool that really helps with incubation iteration. It's a tool that allows artists to make more tools. So basically, it's a tool maker, and I'll show you what I mean by that when we get into the video. What we wanted to do was to allow ourselves, the whole team, to create tools really quickly, and allow artists to be able to create tools, especially ones that are more technical. It also allows artists to share tools, even between disciplines. And then the best part of it is it allows every artist to personalize their own tools, right? So some artists like to use fewer tools, some artists like to use a lot of tools, and this really empowers them to just create their own tool suite. So the tool is very simple. What it is it's a window that allows them to load different shelves, which we call toolboxes, and then on those shelves you can create additional buttons, and basically it allows you to customize those buttons however you need. You can introduce Mel buttons, Python buttons, and you can specify icons, and you can then also specify how they are laid out and how they are being displayed on the tool. So here in this example, I'm going to go through how to create a brand new toolbox, and I will name this toolbox the new box. And in this example, I'll create a new button that will help a user incrementally save. So I'll give the button label a name, like Save Plus, and then I'll introduce the command, which is incremental scene save. And I know that this is a Mel command, so I have to change the type to Mel, and I say OK. And any artist could have done this, right? So they've already created a button for themselves. And then I've forgotten to put an icon to it, so let me specify this plus circle icon. And I say OK. And there you go. And then now I have new button, right? And I can go a little bit further than this. I can already go in and load a whole new tool shelf for an export, right? So like a whole export toolbox that has already been defined, which has the validate button and the export button. And then I can go also introduce the whole animation suite. And then here you can see I can bring in all the animation tools that an animator would never need. And then I can drag and drop these toolboxes right next to each other as tabs, or I can move them to be separate and lay them out however I want. And I'll show you a different example here. This is the modeling tool shed. It has 3 toolboxes, but let's say I wanted to bring over the new toolbox that I just created with the iteration of the save. So I can basically look for this new box that I just created, add it onto the shelf, add it to this tool shed, and then I can replace wherever I want that tool to be, and now it's part of that modeling tool suite. And all I need to do now is just save it, and it's done. And you can just go about doing this for every single discipline. So this is another example of the rigging tool suite, and you can see that you can also dock the tool sheds to the left or right or any direction you want, and then you can really benefit from creating a lot of tools really quickly, especially if everyone's creating a tool and it's all shared. So as you get closer and closer to production, you may consider the fact that you might need to outsource your work. And to be able to do that, you would need to export your environment, your tools, your projects, and plugins that you might be using. So I'll show you a very simple way to do that with how Maya's environments are set up. And it's a really simple step that can be used for creating environments that you can send outside of your studio or even to other teams within your studio. So I'll take you through the video. So in this example, I usually create a folder called My Sandbox, and in that sandbox I'll create another folder called a template, and inside that template I'll have a text file which is a bat file, and that bat file will allow you to basically set up an environment that would simulate an environment that you have inside your studio. And the reason why I put it into a template file is so that I can copy it, and then after copying that folder, I can rename that folder the name of the outsourcing company that you're about to outsource to. And once you have that, you can basically put all your scripts, your plugins, your projects and stuff into that folder instead, and then you're ready to zip that up and send it out to outsourcing. So let's go into that bat file and see how it works. So for that bat file, the most important line is the line that says set Maya app dir. What this environment variable is it's the environment variable that defines where Maya will store all of its preferences, the project, the plugins, and basically everything that's relative to how Maya works. And the way that we do this is we set it to the parent folder of the current file that's being executed. So in that script you can see that I'm setting it to the name of the company, right? And it doesn't actually matter where that folder sits. It can sit somewhere else in the outsourcing company's environment, and it doesn't care because it's all relative to this path that's being set. So once you've defined that route, you can start defining other paths that you would like to overwrite, like for example, the Python path. And the Python path is where you would put things like your Python scripts. And in this example, I'm just setting it to the My app dir, which is the root path for the preferences and everything that we have for our project. And we're setting it to a folder called Python. But you can really rename that to whatever you want. Next, we're setting the My script path for where you're going to put the mel files, and I call this mel. And then after that, I'm going to define where the plugins are going to sit, which is the my_plugin path. And then finally, I'll set where the icons are going to be for all the tools I will create. And then last is the line that starts up Maya. And you'll see here, after I execute that file, you'll see that Maya will automatically create the 2020 x64 or whatever version that you're using. It will create the project folder and the scripts folder. And within that 2020 folder, you'll see that it's exactly like what you would see in the My Documents user folder. It will contain your prefs, your presets, your scripts, and in the projects, you'll see it's the vanilla default project, right? But you will normally put in all of your own projects. So if you're outsourcing your characters, you would put all your character projects in there. And then the scripts is where you can put all your Python scripts and your mel files. But as you can see in our bat file, we had split that out. So I want to be able to put my Python and mel scripts in their own folders. So I'm going to create a mel folder, and I'm going to also create the Python folder. And when I write my tools, I also want to put my icons in the icon folder. So I've overwritten it so that I can put all the icons in this folder. And then lastly, I need a place to put all the plugins that I'm using in the current project, so I'll put all my plugins within the plugins. And that's about it. All I have to do is just copy all of my files into this folder, the plugins, the scripts, the projects, and then I can zip this up and I'm ready to work with outsourcing. So hopefully you've survived this journey and you finally made it into production. Well, congratulations. You've actually solved all of the main challenges that were stopping you from shipping in the pre-production phase, and you're ready now to complete your journey. Hopefully this has given you some key takeaways with how to rapidly iterate during those phases. Thank you for watching my presentation.